Nanotechnology and latent fingerprint. This article was taken from the International Journal for Forensic Science and it's presented by Arjun and Karpin. Forensic science has become more interesting in scientific topic to investigate with the advancement in science and technology, in which nanomaterials have attracted a lot of attention in the field of nanoforensics research. Fingerprints are important evidence in any crime scene, and nano-based techniques have a lot of potential in fingerprint investigation in the future. Fingerprints have often been and still are considered one of the most valuable types of physical evidence for personal identification. The prints left behind at a crime scene are usually latent or invisible fingerprints, and thus the distinct ridges can be detected by using nanomaterials. The use of nanomaterials such as silver, silver oxide, silicon dioxide, aluminum oxide, gold, carbon, and silica with porous and non-porous surfaces can produce ideal fingerprints which can be used in the court of law. As a result, this review study focuses on the use of various nanomaterials in the development and detection of latent fingerprints. Nanomaterials and latent fingerprints. According to the Forensic Science Journal International, nanotechnology has been a catalyst for the development and advancement in forensic sciences for the past decade. Nanomaterials has changed the dynamics of science by using the unique properties from molecular level to characterize matter in many significant ways. Nanomaterials can be identified as particles with 1/1,000,000th of a unit in diameter, which is approximately 40,000 times smaller than the width of a human strand of hair. Due to this physical and chemical characteristics, nanomaterials have allowed many technological advances in forensic science in many specialty areas, such as fingerprint visualization, drug and pesticide detection, question document examination, explosive detection, petroleum product detection, also in body fluids, DNA materials, and other trace evidence. Fingerprints have been used by criminal justice system to identify individuals for the last 100 years. It is one of the most important evidence due to the uniqueness and immutability for personal identification. The study of fingerprints as means of identification is called dactylography as one of the fundamental sciences in criminal investigation, whereas the scientific study of frictional ridges, patterns found in fingers, palms, and hands, toes, and soles of feet is known as dermatoglyphics. A fingerprint is an impression left behind by the skin found on the inner surface of fingers. The skin of this area is called friction ridge skin, and hence fingerprints are the result of minute ridges and valleys found on the hand of every person. This friction skin is found on the fingertips, fingers, palms, and feet of human, and it's unique to each individual in the world as well as permanent in their arrangement. This rich detail contains a variety of various chemicals that come from natural excretion as well as various chemicals that come in other forms. The ridges form before birth as the fetus develops in the womb and barring a deep-seated injury which penetrates through the epidermal layer of the skin. Their arrangement will remain unchanged until death. The two general categories to describe fingerprint evidence that may be found at a crime scene are invisible or visible finger marks and latent fingerprints. This investigation will be dealing with latent fingerprints. The three glands which are responsible for the natural secretion of skin are subiforous, acrine, and apocrine glands, and sebaceous glands. Sweat contains greater than 98% mineral 0.5% and organic compound 0.5%. Thus, the identification of latent friction skin from evidence are collected at the crime scene is crucial to solving many crimes. Physical methods involves physical interaction with impressions deposited to create latent finger impression, whereas chemical method develops latent fingerprints by chemical interaction taking place between the developer and the constituent of sweat. Latent fingerprints are one of the most collected evidence from crime scenes as physical evidence. However, most of the prints left behind are invisible, and as a result, with human intervention and other poor techniques such as poor services, environmental conditions, these prints cannot be used in the court of law. Therefore, in order to improve latent fingerprints, nanotechnology and forensic science has adapted nanomaterials as an effective method. Nanomaterials and latent fingerprint. When latent fingerprints are left at the crime scene, a detail-rich pattern can be identified. Nanoforensics allow for the viable new technique to capture these invisible prints, which can be used as physical evidence. Nanomaterials such as silver, silver oxide, silicon dioxide, aluminum oxide, gold, carbon, silica, and carbon dusting can enhance these surfaces, therefore allowing investigators and crime scenes technicians to retrieve these prints. For these new techniques and using these materials such as silica, nanocarbon powder, silver nanoparticles, zinc oxides, gold nanoparticles, aluminum oxide, creates definitive patterns which can be used in the court of law. Adopting these new techniques will allow latent fingerprint, which was difficult using the conventional process. And in many cases, we have seen throughout this study that they were unable or unfit to use in the court of law. Using nanomaterial and nanoanalysis are changing the investigative process to a more reliable, precise, and quicker processing time. According to this study, using nanoparticles will allow examiners to observe more detailed characteristics from these prints. As been said before and established, fingerprints is one of the most important pieces of evidence when it comes to determine a suspect's identity. As fingerprints are unique, they portray the person. No two people have the same fingerprints. Apart from enhancing the properties of fingerprints with appropriate techniques, DNA can be extracted from them. The new approaches for developing latent fingerprints by nanoparticles are far superior than the conventional ones that are already in use. These particles can simply be used to reveal fingerprints on a variety of surfaces and also have tremendous potential for more precise finger ridges. This is due to nanoparticles' superior discernibility over commercially available traditional fingerprint materials. This approach of latent fingerprint has greatly increased the use of nanoparticles in the field of forensic science and made sample analysis considerably easy to more and accurate. Metal nanoparticles such as silica, silver, gold nanoparticles have recently shown significant potential in fingerprint analysis. As described before, the microscopic properties of nanoparticles improve the disparity in print impression by enhancing the endogenetic material on the elevation of fingerprints. Physical evidence of latent fingerprints. Latent fingerprints are impressions of friction skin on the human fingers or palms which can be transferred to other surfaces. Latent fingerprints can be retrieved from crime scenes by two common methods. How latent fingerprints are collected. Latent fingerprints has been established to collect prints from a crime scene due to unique patterns. Methods involve identifying and comparing ridges pattern. Ridge patterns include level 1, which include the loop, whorl, arches. Level 2 are minutae, and level 3 are sweat pores. Why latent fingerprint use nanomaterials? In contrast, the fingerprint on the paper surface was better when silver nanomaterials were utilized. These nanomaterial particles, such as gold, silica, silver, are widely used for latent fingerprint detection than other materials due to its enhanced visibility of fingerprints picture, ridge patterns, and sweat pores. With the advancement of nanotechnology, forensics experts will be confronted with a variety of nanoscale evidence in the future. Nanotechnology has a great potential for development and detection of latent fingerprints, which helps in criminal investigation. To allow for unsuitable environmental conditions, nanomaterials are much more effective due to its sensitivity, selectivity, and processing time. Some of the materials used in nanotechnology and latent fingerprints include that of utilized reliability of scientific methods and spectroscopy, such as dynamic light scattering, DLS, Raman microscopy, scanning electron microscopy, or SEM, transmission electron microscopy, or TEM, atom force microscopy, or AFM. These are effective methods which can be used in applying nanomaterials for better processing of surfaces. Nanotechnology and latent fingerprint. The use of advanced nanotechnology can provide a wider scope of techniques to solve crimes for identification purposes. Nanomaterials can detect fingerprints on weapons, biological samples, variety of surfaces, and other organic residues. Nanomaterials can enhance nanosensors for evidence and collection of crime scene. Nanoparticles are powerful extractants for DNA, PCR, and observance in sample analysis. Nanomaterial fingerprints detection on sebaceous, eccrine, and upgrain sweat glands and surfaces are effective. Most latent fingerprints cannot be detected from contaminated surfaces in using the conventional technique. However, with nanomaterials and the advances with nanotechnology, latent print can now be detected on some of these porous and non-porous surfaces. Nanomaterial will allow for the disparities such as contamination, time lapse, and other environmental conditions such as temperature, pressure, porous surfaces. Nanomaterials have been a new technique such as powdering, a vacuum method, deposition of particles reagent, pouring latent fingerprint can be observed and analyzed. Latent fingerprints with water-soluble CDET quantum dots. This is a technique used in highly fluorescent water-soluble cadmium telluride. Quantum dots was available to detect fingerprints on non-porous surfaces. Zinc oxide and silicon dioxide nanomaterial used to detect fingerprint on wet and dry surfaces, forming distinct ridge patterns. Nanomaterials such as metallic oxide, semiconductor, quantum specs, fluorescent mesoporous are all new techniques used to enhance latent fingerprint. These techniques are proven to outperform conventional methods and protect evidence, which may become important for criminal proceedings. Nanotechnology can right the wrong of conventional fingerprints. Nanoplatform can provide the effective methods to allow investigators to detect, preserve, and retrieve valuable fingerprints from crime scenes over or for a duration of period, including and catering for environmental or adverse environmental conditions. Historically, the precedent was not the case, where most the conventional method use some of these techniques for partial fingerprint, which was used in the court of law, and many innocent people were sent to jail. The case in which was tried, this is one of the classical examples. The first case which was used fingerprint in the United States was based on 1911, where the People versus Jennings. Based on the evidence, latent fingerprint was at that time at its infantile stages, and as a result, the reliability and validity of the technique was in question. Although there were no confirmatory method to verify the uniqueness of the print, the court ruled the admissibility of an expert witness. Latent fingerprint under scrutiny. Latent fingerprint with conventional techniques came under scrutiny in 2004 when Brandon Mayfield was arrested for bombing of a commuter train in Spain, based on a partial print retrieved from the crime scene. This case was an embarrassment to the FBI, which were prompted to render an apology as a center of skepticism of people's mind. Latent fingerprint and conventional techniques came under scrutiny in 2004 and in many other cases we have seen recently. Some of the legal consideration of expert witness. Following a 1993 Supreme Court ruling in Daubert versus Merrill, judges were required to apply scientific expert to testify, which was a decision from the U.S. Supreme Court in 1993 based on the precedent on Frye versus the United States. Frye versus United States, the court ruled that expert opinion based on the scientific techniques is inadmissible unless the scientific technique is accepted by the scientific community. Is nanotechnology and latent fingerprint admissible? According to the Journal for Forensic Science, nanotechnology and its imminent techniques for latent fingerprint can provide crime scenes investigators with science to solve criminal cases with much more reliability and certainty. Based on the available research, the validity reports for nanomaterials and latent fingerprints, I believe this technique should be admissible and should be considered as the gold standard for latent fingerprint. Furthermore, using conventional instrumentation, some of the microscopy techniques such as DLS, SEM, TEM, and AFM are compatible with nanomaterials. Based on the in-depth research on nanotechnology and latent fingerprint, I think the drawbacks are small when it compares to validity and reliability. However, cost effectiveness, materials availability, trained personnel, and the accessibility of technology in all the jurisdictions are some of the loopholes which can be foreseen. Nevertheless, when compared to seek justice for the innocent and punish criminals for heinous crimes, the loopholes are not near comparison. Nanotechnology contribution to forensic sciences. The discovery of nanotechnology and its application in forensic sciences investigation are of great significance for the standardization and reliability. According to the Journal for Forensic Science International, nanomaterials have been impacted forensic science tremendously by detection of explosive, trace petroleum, DNA analysis, nano trackers to estimate the time of death. And this concludes this review of nanomaterial and latent fingerprint. Attached here are my references, and thank you.